Let's start. Okay. Today, first of all, hello everyone. Today I'm going to talk about observability and building observable Go services. And I hope at the end of this talk you will have an idea or maybe a survey of the field, lay of the land about observability and Go. So first of all, who I am. My name is Kemal and I'm working for Red Hat for observability platform team. And my team is responsible for building a observability platform which kind of collects and stores these observability signals. And we aim to provide insights using and correlating these data. So that's why I picked this topic. This is what I do daily. And furthermore, this platform is all made of open source projects. So all of the team members kind of contributing to upstream open source projects as well. And we are also SRE. So we have SRE responsibilities, which means we are on call. I'm actually on call right now. I hope I won't get any alerts or pages, whatnot. Wish me luck. So that's why we use all these practices that I'm going to tell you in our daily systems, production systems. So I'm an open source maintainer. I'm a Thanos maintainer, a Prometheus contributor, and as much as I can, I try to participate in SIG observability, CNCF SIG observability, and Kubernetes SIG instrumentation. Besides all this, I'm really into observability monitoring. Obviously, you can tell that. And I'm also passionate about distributed systems and databases. You can check out my Twitter and GitHub, and I will be sharing the slides of this talk afterwards in my GitHub. So let's start. So the basic question is, what is observability? Like the first question. Observability, everyone has different definition on this topic, but let's start with a Wikipedia definition. So observability concept is coming from control theory, and it means the measure of how well an internal state of a system behaves and what we can infer from that. But it's basically for us software engineers or SREs, it's the ability to ask questions and get the right data and get some internal insights from the running system so that we can check if the current system is healthy or if it's not, why not, and so that we can dive in and debug. So observability is a broad topic, and I don't want to just focus on the abstract ideas in this talk. I really want to focus on the pragmatic aspects of observability and observing Go services. But if you want to dive deep in observability topics, there is a really nice talk which Richard gave in 2019 in FOSDEM. This is Observability 101, and really highly recommend this talk about to grasp the ideas and abstract concepts behind observability. So for us as a Go developers, what does a properly observable system in Go look like? That's the key question. So for most of our systems, good observability is simply more than testing. As I told you before, it's about asking questions. So observability kind of enables smart organization to focus fast deployments and fast rollbacks so that they can provide highly available services. But there is no single answer to this question or a package or a single library that you can just magically put in there. And or as previously has been done in our community, there won't be any agents. Automatically, we can just include our stack and we get all the collect all observability signals, and so that it's kind of more involved process. And I'm going to try to explain those concepts as much as I can. Also, the observability space is kind of fractured. And each vendor has its own opinion, so you will be seeing lots of controversial or contradicting ideas when you talk about like observability and monitoring. But what I'm going to do is like I will try to include as much as I can in this talk. So this is an old concept, pillars of observability. When we talk about observability, we actually have two types of events. This is kind of aggregated observations and discrete events. But there's this three major ways that we collect the signals. It's not just three, but these are the three major ones, which are like metrics, tracing, and logging. Metrics are basically numerical data types, and they are aggregated observations, and they're really easy to scale. Either it's push-based or pull-based, and you can do math with them, so you can actually do a lot of magical things with them and predict how would your system behave. Moreover, we have logging, which is mostly a bit more verbose, and it's text-based mostly, and it's more rich when you think about the metadata, and it's the only downsides maybe it's like scales linearly, so it's not easy to scale, and you also kind of produce a lot of noise in your logs, and sometimes it's not easy, the most easiest thing to just follow and make sense of. And the traces are like also maybe the richest signal type or pillar that provide observability insights, but it's also the most expensive one. And it's kind of gives you an idea how your program executes, execution path of your program, basically. For that, like when we talk, the best way to actually provide like an efficient experience to your users, in order to provide efficient experience to your users, you need to combine and mix and mesh all these signals, and so that you can easily react to any incidents on your systems. For that, it kind of starts with metrics, at least for me. Metrics are good for alerting and dashboarding and ad hoc queries and exploration of your system. And logs are good for establishing order of events and getting more detailed information about the system or the execution path. And traces are most likely to understand each individual component of the system, or regarding distributed traces, like how would your system behave in order to conduct more involved, more complex operation. So if you want to, again, know more about these topics, Peter Borgen actually explains this better than me, and he's really an experienced Gopher, one of the first, and he's very visible in the community, so you can check his blog. He has a blog post especially about this topic, so I'm dropping the link here so you can check it. So everything starts with instrumentation. So that's what we're going to do. We will create an application, a demo application, and using this demo application step by step, we will include some code pieces. We will use certain libraries, and we will try to collect all these observability signals and then try to make a sense of it. So this is how it looks like. I created I will give the link at the end of the talk. I created this Go application, which has two binaries. One is a proxy load balancer, and the other is a backend, so that we can individually scale the backend part of it, and we can just use a load balancer to balance out all those things. And I'm not a very creative person. That's why I just went with what I know. And Prometheus has a protocol called remote write, which enables you to synchronize or like send your collected metrics to a remote server. So I implemented a handler, a conformer for that protocol, and use Prometheus itself to push the metrics through the system. And like we will see this step by step, and this applications has all necessary observability signals. I don't know if it's necessary or we covered all possible options, but as much as we know. And we will see how things in action on a real code. So let's start with health checks. These are the most basic observability signal that you can actually expose, and they're kind of, but even though they are really low-hanging fruit, they're really useful, especially nowadays. Our infrastructures are flexible and they kind of know how to probe our workloads. And if you provide these health checks, for example, take Kubernetes, and you can have health checks and ready checks so that your infrastructure knows where to funnel the traffic, or if a certain application is not healthy or not, so that it can maybe reprovision it and restart it, whatnot. So this is kind of the starting point to provide self-healing systems. So for that, one of the things I do, I start with adding a HTTP server. Especially, this is dedicated to the debug endpoints and just to expose the signals. For this, it's just a basic server creation, and we are using a library which will I explain soon. And we just register a couple of handlers which responds to the health and readiness checks. One other trick in here, in order to collect the data from our application, like the health status of our application, since we have two servers, one is public. From this server, we can actually, using this library, query the public server, and if it's healthy, we can just respond accordingly. So when we query those endpoints, we get basic responses. Most of the times, infrastructures doesn't care of the body of this payload. They just check out the HTTP status codes, and by just giving this simple signal to your infrastructure, you gain a lot of flexibility by start. So for this code pieces, I use the first library from MetaMatte. It's called Signal. It provides you an internal server and some health check libraries. And this is really similar. The second option that I provide, this is Heptio from the health check, from Heptio, the health check library. These has built-in functionalities to query DNS databases, whatnot. So you can actually form complicated health checks by querying your dependent services, and then you can just avoid any cascading failures to your systems. So you can also take the approach to just do it by yourself, which is pretty fine, especially in the Goland. I'm just dropping these libraries just for the convenience. So our second major point will be the metrics, as we talked about previously. Metrics are the easiest to scale and they're cheap. So we will start with that, and so that we can build our alerts and dashboards starting from those. So metrics are cheap signals, and they're numerical data types. And most of the libraries or the instrumentation systems, monitoring systems provide these basic types, which are counters, gauges, and histograms. And These metrics also combined with the external labels to give you context, metadata, or like the static information, for example, static target information about your working payloads. So for this demo, we are going to use Prometheus, which I am very familiar with. Prometheus is a free software application used for event monitoring and alerting. And Prometheus is pretty popular and like highly scalable and really battle tested metrics application. It's actually comes from SoundCloud, and the ideas originated from Google, I guess. And like funny enough, I'm living in Berlin right now, and SoundCloud, the Prometheus invented in here. So we have a pretty involved community in Berlin. So we start with Prometheus, and specifically we will use Prometheus Client Go to instrument our application. Client Go provides all the necessary facilities and APIs for you to instrument your application. So it starts with creating a registry, and basically from that registry, again, your internal service, you just register a handler and expose from /metrics. Prometheus is a pool-based monitoring system, so it will discover your services and application, and it will make this request and collect those metrics from your system. Between the scraping endpoints, because it's like by default, it's every 15 or 30 seconds, and your system will aggregate those metrics, and Prometheus will just scrape those whenever it can. So when you put this registry and put the handler in place, when you go to that endpoint, you see something like that. And not exactly the same metrics probably, but you will see something, at least an up metric by default Prometheus provides. But maybe this is not enough for you, and that's why you can add different collectors. Okay, I guess, yeah. As in here, you can see we are adding different collectors. This Vada collector is kind of a library for Prometheus from client libraries. So you can add these collectors, and automatically they can collect instrumentation metrics from your running server. So in this case, we are adding a couple of them. We are adding for one from version, one from module versions, and one from Go collectors. So by default, this will give us, for example, metrics about the build info. These codes, like these are info metrics. So it will tell you like what is the version that's running in your production system, so that you can know like if you deployed a faulty version or if you have anything wrong with that version. So you can roll back or change, you can react on it. Also, the Go collector itself provides lots of runtime metrics just like that, and you can actually find predefined dashboards or alerts depending on this. There are a lot of options. By just adding a single line, you expose those metrics as well. And one other thing from the community, as we talk about the version, this is also about our dependencies. Maybe you want to check out frequently. Maybe you want to run a routine to check what running versions of your dependencies, and if you have any security vulnerabilities depending on those versions, so that you can alert on them and take an action and redeploy your applications. So like by just putting a couple of lines, Prometheus gives us this cheap metrics, and we can just like put alerts and start to get take action on them. So if you can do one thing for your application, I would strongly suggest to expose metrics from your application. So another point, which I call power of middlewares. So we have this applications, we keep building microservices, and they're more or less doing the same thing, and we are serving HTTP in this case. And sometimes we just need to, we just duplicate a lot of code. So to prevent this, we have this middlewares that we can combine our handler chain so that we can have by default common shared code. And we have the same thing for Prometheus as well. And we will start defining one. And we will create a metrics track, which we will have the request information, request and response information for our HTTP system. And we will initialize our metrics. This is an histogram, and Prometheus kind of exposes like aggregated cumulative histogram buckets. So you need to define the buckets prehand, and you need to synchronize the buckets according to your latencies of running system. So then we create our middleware by chaining them. I know this code a bit like it seems like a cumbersome one, but this handler itself also provided as a library from Prometheus, so you can just check it out. And it's also in the demo app. Will help you to just get along with it. So when you have this middleware, you initialize your middleware and you combine with your actual endpoint so that you can have this metrics, this 4 metrics about your service by default, depending on each endpoint. And this middleware kind of adds certain labels, so you can have a distinction between each basically path and endpoint. So this is also how it looks. You can just like run ad hoc queries in Prometheus UI. Prometheus kind of provides this, and it is a query language, and it's kind of it has a steep learning curve. It takes time, but you can do like really powerful things with that. And there are, as I told you before, we have things called monitoring mixing for example, Prometheus ecosystem, so that you can just share your alerts and these queries. A lot of best practices out there, so you don't need to reinvent the wheel. So more on this topic, I recently gave another talk about Go instrumentation best practices. This one is specifically on metrics part. I gave this talk in GopherCon, Go Days Berlin 2020. So you just check it. It's like the recordings are also available, and I'm also putting the link here if you're interested. So second observability signal. This is the second observability signal, but the third trick, it's about logs. So when we talk about logs, there are two types of logs. We talk about structured and unstructured logs. And unstructured logs are like, I'm sure you already, like this is the lowest thing is hanging fruit. Basically, you just put a log line into your application, and if you don't, you just print something to the console, and you kind of understand what's going on with your system. But when they are unstructured, it's like they are hard to parse, so they are not machine readable, and they are like harder to take action on them. So they're just like bunch of noise. Only thing you can do with those logs, get into logs and check out the logs yourself. And this is not the best, most efficient thing that you can do. But if you have the structured logs, you can actually parse and aggregate and using metadata information, and you can actually use process the logs for analytics purposes, or it will make the log searches seriously easy. So for that, I prefer to use one of these two libraries. My favorite one is GoKit Logger, because it's simple. It has a simplest interface out there. But I also have a lot of nice experience using Uberzap. I don't prefer using JSON as structured output, but it's possible for both of the libraries. You're just using a simpler format, which I will show you in a minute. So when we create our logger, it comes with certain levels, and we add and aggregate this metadata for each logging event that we put in place. And with using the GoKit logger, this example is coming from that, you can actually combine the context and propagate the contexts downstream of your app, and it will help you to organize your code better. So this is an initial code where you create your logger, initialize it. This has some boilerplate code because we want to just filter out certain levels, and we want to take those configuration arguments from the command line. So after we have our logger, we just initialize it with our configuration or logs, and this is how we actually log out from our system. As you can see, we have certain key value pairs, and we have message, and it says exiting, so that when you see this in actions, you can also have beside message, you can put the error in there, you can put some other values, time values, or status code, whatnot, and at the end of all this instrumentation, you will get something like that. And you will have the color information, the attributes that you already put it there. It's simple. It's like human readable as well, also machine parsable. So the simplicity I prefer in writing with Go programs. So this is how we initialize our logger. But this is, again, it's always help us to have some middlewares for our HTTP action, HTTP request handling. That's why I also I'm showing a basic middleware for logging part as well. So we have this in here. We kind of log the protocol information, maybe request ID and whatnot, so that we can kind of correlate our data with our request when we want to debug. So this is how we combine our middlewares. We put the logger, again, we wrap our actual handler, and we also wrap with the request ID handler, which kind of injects that request ID in place, so that we can put that into logger, and we can use those loggers, log statements in our application. So when we expose these signals as well, we can use these signals using kind of a new project, kind of a CNCF project, very similar to Prometheus. We kind of say that is a Prometheus for logs, the Loki project. It's getting a lot of traction right now. You can just like install this into your infrastructure, and Loki also provide a way to a tool called Prometheus to scrape your log lines from your application and sync them through your logging infrastructure. And since it's coming from Grafana also provides nice log panels for Loki as well, and the data sources available, and you can just like plug all those things and have these nice panels. So other observability, one of the other observability signals is about tracing. Tracing is kind of the most one of the most costly, but the richest, and it kind of helps you to track the execution path of your actions throughout your system or a single component. And it has this idea of spans, and it kind of builds this hierarchical tree of execution, so you can track an action throughout your whole system. So for this, in our application, we're going to use Jaeger, which is also another Go project, another CNCF project. I guess they are also graduated as well. And it's scalable and super simple. We have nice experiences that's running that system on production. So how we add Jaeger in our system? For that, we are going to use OpenTelemetry. And for OpenTelemetry, we will build an export pipeline dedicated to Jaeger. And then we initialize our tracing provider. And we will use this tracing provider to inject our spans into our execution flow. So tracing is kind of an involved process. So this is our handler, basic handler, and for this handler we want to observe trace and observe certain parts of action ourselves. So we create this spans with tracer. These OpenTelemetry has really convenient APIs to do this, and we name them so that we can track them. So for a receive, at top level, we create a span, and for each sub-action, subsequent action, we also create the spans, and we will see how they look in a minute. So this is another span adding for the same action for another subsection. So also with this spans, this is how we manually do this, and we can do the same thing using tracer as well. So tracer middleware as well. So this is also another middleware. So first, if we have this request coming from another service, we kind of extract this context information, tracing context information from the request and put it into our context. Then we kind of create our own span for each request that we have and push it down. So we can all like correlate all those things together. So when we expose this tracing information, we kind of push those things to the Jaeger servers, agents, or collectors themselves. So then Jaeger also provide a nice UI for this, and you can actually do certain searches depending on your services. And from that searches, you can collect your observations, and you can see them in a timeline, and you can click around and see like these dots, for example, in the graphs are scaled out corresponding to the time they take. So you can actually see which actions are taking much more time. So when you click one of the actions, one of the spans, you kind of see this hierarchical tracing information, and you can check out individual actions and how they behave. So I really don't want to take too much on tracing today, because we have another upcoming talk on distributed tracing and OpenTelemetry. Probably Fahri will dive more in depth in this talk and talk about the tracing. So if you are interested, I highly recommend you to watch that talk as well. So one of the extra signals I want to mention about it's profiling. This is the richest one. Profiling is the kind of the collects and aggregates the resource usage of a runtime of Go and kind of exposes that. For that, we are using pprof, and with pprof, we are taking snapshots of our runtime, and we can see the what kind of memory allocations we have, how much CPU do we use, which Go routines kind of idle and waiting. All those informations can be obtained by using pprof, and it's really easy to include pprof in your system. This is kind of involved, and I only recommend profiling if you have really performance critical applications to debug. There are a couple of knobs for profiling which we can set. These profile rate and fraction rate we kind of get from command line, so we can inject this configuration to our runtime and configure the amount of data or amount of snapshots that we take. As I told you, pprof is super easy to integrate. There's a pprof library in the standard library. You just add a pprof package in standard library, just add to your application and expose certain endpoints, and automatically you have all those information available from your system, which looks like this. It's ugly, but it has a lot of information, and it's really easy to add. And then if you really want to understand nitty-gritty of runtime, you can just check it. It's really helped you to learn a lot of things. I will recommend this blog post from Julie Evans. I put the link here. It's really it's a really helpful source for you to understand and begin with profiling. There is another idea which regarding observability and runtime system. It is continuous profiling, and for continuous profiling, the idea is we have the snapshots and we kind of expose all those profiling information for our production systems as well, and we will we have the systems to again take the snapshot so that when we need it, we can check out those snapshots, and in those time frames we can check, we can see what is the resource usages of our Go runtime. So there is a really nice article from JBD, and she kind of talks in depth how they use continuous profiling with Go programs in Google. So you can check it out. For this part, we're gonna use for our application, we're gonna use Conprof, which is an open source project, which is kind of maintained by my team. And using Conprof, we will take those snapshots from our running service. So Conprof also really a nice UI. You can see you can just query certain time ranges, and from those time ranges, you get the snapshots, and you can click those snapshots to see the actual pprof. This is more like detailed example for that. Like when you click the dots, what you see is the real pprof UI, I may say. Okay, so all of these comes to actually this point, correlating all those observability signals, because individually collecting all these signals actually doesn't give any like, of course it gives a lot of information about our systems, but the power kind of comes from when we kind of correlate them. So our life cycle kind of starts with an alert, and usually we built this alert using our metric system. We got alerted, and we go and check our dashboards. Maybe we check some ad hoc query, and from that ad hoc query, maybe we jump into logs. Maybe from those logs, we jump into traces and then profiles, and we come up with a fix, understand what's wrong with our system, or we do the same thing to optimize our code base as well. So in our production systems, we kind of use this. We use Prometheus for metric system, and we run our workloads on Red Hat OpenShift, which is kind of a distribution of Kubernetes. And we use Jaeger and Conprof on our production systems. So, for example, to give an example, we seen recently a spike in our latencies, and we didn't understand what's going on. This happened after we rolled a new version. Rather than rolling back, we wanted to understand what's going and what is the exact situation with this problem. And it started with ad hoc querying. We check the Prometheus, then we jump into the logs, and from the logs we find that there is a slow query, and we can see this in our log line, and we have a trace ID now. We grab that trace ID and we kind of query against the Jaeger and check which spans and which operations are kind of taking much time, and we kind of then I understand this which component actually this latency comes from, and we dig in that component and which actual actions this latency is produced by, and then in the same time frame by using Conprof, we check check the time frame and find a couple of snapshots, and from that snapshot we find out related pprof pprof snapshot, and from that snapshot we can see like what are we doing, what kind of allocations are we doing, or are we using much more CPU and whatnot. And we actually, with this, we kind of discovered we were allocating and spent a lot of time on allocating memory, and we realized that we need to optimize for the CPU usage, and we did that, and with the new version we solved this problem. About the correlation, as you know, like Grafana is one of the most popular UIs for aggregating all those observability signals, and Grafana is already on top of all these tools, and you can correlate maybe all those things in a single UI. For that, Grafana has in a Prometheus data source. You can just use it. It also has a Loki data source because Loki also comes from Grafana itself. And there is also a Jaeger data source. And you can just like put these data sources, and rather than jumping through different UIs, you can actually see all those things in a Grafana dashboard. And soon we will have a Conprof data source. It's baking, and there's actually a PR to add Conprof data to Grafana as well, so that you can, for all those signals and all those CNCF tools, you can use a single UI. So it's online, the demo application, and you can check it out. Like the instrumentation part is completely done and it's fully functional. It's kind of lacks the integration with Loki and Jaeger, which is on my top of list, but I will be updating this repo with the Kubernetes manifests and whatnot, so that you can have a useful configuration, and you can actually use them in your production, or at least start using this provided examples. So by that, that's it from me. I hope you get what you want, and I hope this will help you to build more observable Go services for you. So thanks a lot.